I'm not sure I've even been labeling these things. I can't remember. We'll call this one number 11. Okay, so we're using the quadratic formula to find the solutions of these equations. Let's get this thing in standard form. So we have 5x squared minus 2x plus 2, and that's equal to 0. Right. So a was equal to 5. We're going to say b is equal to minus negative 2, and c is equal to 2. Okay. Alright, so we just plug it into the formula. Do we remember what the formula was? Well, I'm not going to write it down, so let's see if we can remember. So remember, we start with a negative, and then we got minus 2. So let's go ahead and put that in parentheses. Plus or minus the square root of b squared, so that's going to be negative 2, squared minus 4a, which is 5, and c is 2. Right, and it's all over 2a, so 2a, which is 5. Okay, so now what we want to do is simplify this thing down. So we have x is equal to, so we have negative 2, a negative negative makes that positive. Negative 2 squared is 4. Alright, so we're going to have minus, so we've got 4 times 5 is 20, and 20 times 2 is 40. So you notice under here we've got 4 minus 40. We're going to end up with a negative under the radical. So hopefully you know how to deal with complex numbers, because that is what we're going to be dealing with here. So we have 2 plus or minus. So we have 4 minus 40. That's going to give us, does that give us 36, right, over 10. Okay. So 2 plus or minus. Now, we have this negative here, so we take the square root of negative 1, we get I, but the square root of 36 is a nice number. So remember, this is equal to I, and we can break that up as negative 1 times 6. Okay. And of course, this is all over 10, but we could actually rewrite this as 2 plus or minus. We can write this over 10, and then 6 over 10i, and this simplifies down to 1/5 plus or minus 2 goes into 6 3 times, 2 goes into 10 5 times I. 1/5 plus or minus 3/5 I. Okay, so that follows under the section, under the complex numbers section, I think the previous section to this. Okay, so let's take a look at another one. We got 7x squared plus 6x plus 4, setting that equal to 0. So we know that a is equal to 7, b is equal to 6, and c is equal to 4. Right? Okay, so we start with b, which is just going to be 6 there. And then we got b squared. I'm going to go ahead and square that. Minus 4ac. So 4 times 7 times 4 again. Okay. And let's see. What else do we got? Over 2a, which happens to be 7. Okay, by doing the math here, we're going to end up with 7 times 4 is 28. 28, 28 is 56. Oh, what is that? All that stuff under there. Okay. Alright. And the question is, can you break that down anymore? Now you have a negative under here, so there's one thing that we do know. And that is, whoops, that should be a 76i right here. Okay, so we'll just go ahead and break this into two pieces. Of course, that can reduce down, right? 3/7. That can reduce down to 3/7. And the question is, what the square root of 76, does that break down at all? That's the question. And 4 times, I'm thinking 4 times 19. What's 4 times 19? Yep. So actually that will break down to 2. Let's see, 4 times 19 is 76. Okay. Over 14, that's going to reduce down actually. Okay, so we have x is equal to 2 goes into that 3 times 14, 7. And okay, I believe that should be correct there. Should be correct. Okay. I've got a an application. Well, I don't know if it's a real world application problem, but how much screen do I got left here? Alright. We're going to be finding, we want to find some gold now. We want to find two numbers such that their sum, okay, let's see, their sum is 21 and their product is 104. Now I think we did some problems in an earlier section like this. However, we did problems where we didn't have to deal, when we solved the those quadratics, we didn't have to, all we had to do was factor, if I remember right. Okay, so we want to find two numbers such that their sum is 21 and their product is 104. I'm going to let the two numbers be, what do we want to let them be? X and Y. How's that? Okay, we'll let them be X and Y. So their sum is 21 and their product is 104. So we've got an equation here, two equations, two unknowns. Let's just go ahead and solve for x in this problem. So we have 21 minus y. Right, so over here we're going to put the 21 minus y in for x. Okay, so we're going to have 21 minus y times y is equal to 104. And now what we'll want to do is get this thing into the standard form. So distributing this y across, we have 21y minus y squared is equal to 104. It's equal to 104. Okay. And what do we got going on now? Okay, let's go ahead and I'm going to go ahead and take these two terms over to the right hand side. So we're going to have y squared minus 21y plus 104 plus 104. So we're going to use the quadratic formula where a is equal to 1, b is equal to 21, and c is equal to 104. And then we just plug that in. Now, okay, I'm not gonna write x over here because this x will be getting confused with the x that we're actually using in the problem, so I'm not gonna do that. So we have plus or minus, right, b squared. And I'm not going to work this problem completely out. I'm going to go ahead and let you, well, 4ac. And I'm going to give you the answer, so 4a, and let you do the math, the simplifying part on this, over 2a. Right. Okay, so I'm going to let you go ahead and simplify all this out. So what we're going to have here is for our solutions, you should have 8 and 13. Okay. You might get 13 and 8, same thing, it doesn't matter. Okay, so these should be the two numbers that we're actually looking for that will make that will be the solutions to our original equations right here. Right, 8 and 13 is 21, and 8 times 13 should be 104. In fact, I'm not sure if I ever checked that or not. Yep. All right, so I'll let you simplify that and get that. Okay, and so we're over here somewhere. Go to math.com. I don't know where we're at, but that's the website where that's where we should be at, maybe. All right, and of course this is my YouTube channel where all the videos are at. You can go there. So we're looking at we solved some quadratic equations. We found the solutions to some quadratic equations. And we looked at some techniques, completing the square root property, and of course the famous quadratic formula that everybody on the planet should have done at least one time. It's just a rite of passage. That's just the way things are. Okay, and I'll see you in the next section, and at this point I'm not exactly sure what it's going to be. Alright, so I'll see you there. Bye.